Alright, this is just a quick intro to your calculator video, so I'm going to try to be pretty basic here and just assume you guys have never owned a graphing calculator before in your life. So, first step, here's the on button. Hey calculator. Alright, so this first page is just a couple of tips. These graphing calculator manuals are like 500 pages. This is just kind of a quick distilled guide, so obviously there's more to learn, but this is just intended to get you going. So this first bullet, if your battery is getting low, you'll see the screen getting dimmer, so you can hit second and then this up arrow here, so second and then the up arrow, and that will increase your brightness. I don't need to do that because my calculator is fully charged, but just be aware that that's something you can do later. You might run into that. In terms of graphing, and this is especially important if you are in a statistics class along with another algebra class. So in statistics, you see the stat plot up here. So you guys will be creating like histograms and box plots and stuff, and then in algebra we'll be graphing linear and nonlinear equations, functions. So those guys might compete with each other. So when we're graphing in algebra, we're going to go into y equals. So here I just have a really simple y equals 2 plus x, a nice linear graph. And suppose that I wanted to go and look at that graph. So I have y equals, I've already entered that, and I'm going to hit the graph key. But then I've got all this stuff in here. So there's all this extra stuff. That comes from my stat plot. So sometimes you'll see an error message if you guys have competing graphs. And other times just everything will show up on the screen and it just looks insane like this. So a couple of ways you can turn those off. Remember when I was in y equals? If you see up here, plot 1, plot 2, plot 3, those are all statistics plots. And for me, I can go ahead and just hit enter to close those out. So as long as they're not highlighted, then if I hit graph again, now I'm just seeing my straight line, my linear equation, right? And actually skipping down here, right now I'm in kind of a strange viewing window. So you can see my origin is way down here in the corner, and maybe I want that nice little XY axis view. So if you ever want to get to the standard viewing window, you can use the shortcut zoom and then option 6, zoom standard. So zoom, and then for me it's option 6, zoom standard. So I can either scroll down and hit enter, or I can just hit the number 6. And that gets me that centered viewing window. Okay, also just to mention, I did this shortcut to turn off my stat plots, the y equals shortcut. Also, if you have an older calculator, you might need to go into second and y equals, and then it lists all the stat plots, and if you go down here, I can just hit plots off, and that will turn off all of my stat plots. When I hit enter, it says done. Okay, so rewinding right here, you've got two keys that look pretty similar, these two guys, but they're different. This is a negative key, this is your minus key. So if I wanted to enter -2 minus 5, which should give me -7, I would do -2 minus 5. Hit enter, and there's -7. If I try -2 minus 5, actually it's pulling down my previous answer, but anyway, -2 minus 2 minus 5, it's taking my previous answer and combining them, so obviously -2 minus 5 should be -7, not -14. So just keep an eye on that. Your exponent key is this little caret symbol under your clear key. So if, for example, you wanted to figure out what 2 raised to the power 8 is, you use this to get yourself up in the exponent, hit enter, and we get 256. Going back to our graph, this is a really helpful button, and I'll talk about it a lot in this video, the trace key. So I'll show you guys how to create your graph in just a second, but for now let's assume we already have one in there. If you go into y equals, and I've already got this 2 plus x typed out, and then I hit graph, I'm viewing my graph, and that's fantastic. If I want to identify individual points, the trace key up here comes in really handy. So what this allows me to do, when I hit trace, it's hard to see on the screen here, but it says 0, 2, so that's the point that it's highlighting right now. If I say 1, enter, that's saying what happens if x equals 1. And then I get a y equals 3 output here, 2 plus 1 equals 3. If I say what if x equals 5, enter, y equals 7. If x equals -7, -7 plus 2 gives me -5 for my y value. If I type in -5, I get an error message. So remember, we're using the negative sign for negative numbers. And if you get a message like this, you can either hit go to, and that'll take you to the error, or you can always just hit second and then the mode key to quit and get to your blank screen. So that's an option as well. Okay, so that's our trace key and MVP here. We talked about zoom standard already. And then the math key will come in handy later. So I just want to point out under math, which is over here on the left screen, there is just a lot of fun stuff in here. So like cube roots, if you want to graph a cube root function, for example. Over here under number, you have your absolute value function. So we'll mess with that a little bit as it comes up. And then a little shortcut that you can use, second enter. If I hit second and then the enter key, that pulls in the last calculation that I did. So remember, we figured out what 2 to the 8th power was. So maybe I actually meant to type 2 to the 4th power. So I can use that left arrow, highlight the 8, and say, oh no, I meant to type 2 to the 4th power, and then that equals 16. And you can imagine if you're typing something really long, 2 plus 6 plus 5 plus 8 plus 7 plus 9 plus 3 plus 2 plus 1 equals, and then you're like, oh man, it was supposed to be 2 plus 2 at the end, not 2 plus 1. You could hit second and enter, and then just quickly edit that. So that's a nice shortcut to know about. Okay, so now we're on to graphing our functions. So suppose we want to graph the linear equation y equals 4x minus 7. I'm just going to clear out my screen here. I'm going to go to y equals, clear this. So 4x minus 7, I type my 4, and then x is from this variable key here. So if I hit that, my x pops up, minus 7. Notice I'm using minus and not the negative sign. So minus 7. Then I hit my graph key, and there's my lovely graph. And remember, if you have a weird viewing window, you can always go to zoom and then option 6 to make sure it's this nice standard viewing window centered at the origin. And once again, we can use the trace key. So it starts off at our y-intercept here, which is 0, -7. And if I enter the x value, so for example, if x equals just 1, that gives us y equals -3. If x equals 2, we get y equals +1, and so on. Okay, so suppose we want to graph this rational function here, y equals 15 over x minus 12. So I'm going to just hit clear. Takes me to the main blank screen. Go back into y equals. So I'm going to hit clear again to get rid of that function. So first, if I try to type 15 divided by x minus 12, this is not going to be the function that I see on paper. So if I graph this, that's a totally different function than what I'm being asked for right here. Notice that that x minus 12, the whole thing should be in the denominator. This is like y equals 15 divided by x and then minus 12. That's what I just graphed. Don't want that. So use parentheses when you need to. In this case, we would want to put parentheses in here. So you can either clear it out and retype it, or I'm going to use a shortcut where I hit second and then the delete key to access the insert button, and I'm going to insert my parentheses above the 8 and 9 key. So I insert parentheses there, use my right arrow, and then put my parentheses at the end. Okay, so this is actually the graph that I want to see. But there's something interesting that's happening over here where x equals 12 that I can't actually see in this viewing window. So suppose that I want to scoot my viewing window over to match what this axis says. So that brings us to the next page. Alright, so we can try pressing window. And remember, we're in that standard viewing window right now. So our standard viewing window looks like this. This is the minimum x value, the maximum, oops, sorry, you can't see me writing, the maximum x value, and then this one is what's called the scale. So you'll see SCL on the screen. So that means the tick marks count for 1. So let's say we want our graph to match this right here. So we want to go from 0 to 24, 0 to 24 for x and y, and notice that we're counting up by 3s. So we could change this by going from 0 to 24 for the x min, x max. Our scale is now going to be 3. We want each tick mark to be worth 3. Y minimum, 0 up to 24. Y scale, count up by 3 instead of 1. And now if we hit graph, now ours looks like this viewing window. So we can see this interesting behavior around x equals 12. Okay, by the way, if you just got an error message, if you try to do that same thing and you got an error message, I promise you made a typo in your window. And I know you're like, I didn't make a typo. I promise you, go into window, you made a typo somewhere, you wrote something wrong. Okay, so make sure your screen matches mine exactly, matches this exactly. Okay, next page, and honestly I don't use this a ton, but I just want to make you guys aware that it exists. The table feature. So if we look at our graph, I told you guys about the trace function where you can type, x equals 13 and you get y equals 15, for example. There's also what's called the table function, which you can access by hitting second and graph. So here we've got different x values automatically populated with the corresponding y values. So if you want a quick list, you can also use the table function. I want to quickly point out that for 12, the y value is an error. And if I use trace and I type in x equals 12, y is nothing. That's because we can't have a 0 in the denominator, right? Remember that our function was y equals 15 over x minus 12. So when x equals 12, there's what's called asymptotic behavior at the function there. So just want to point that out. If you see an error or if you see nothing in the trace for y, that means you've got some asymptotic behavior. Okay, graphing an absolute value function. So suppose we want to graph y equals absolute value of x plus 3 minus 8. I can go back into y equals. I'm going to clear this out. And remember I told you that that math button had a lot of weirdos in it. So if we go into math and scroll over to number, that's where our absolute value function lives. So if I go ahead and hit enter, I have a fancy new calculator, so it puts up these absolute value bars on either side. So I'm just going to type x, my variable, plus 3, use the right arrow to scoot out of there, and then minus 8. And if I hit graph, I'll see my graph. If you have an older calculator, when you hit the absolute value function, it says AVS, and then it had the open parentheses. Just make sure that you also close the parentheses after. So make sure you put parentheses around the x plus 3. I'll hit graph. And my function looks pretty different from this. That's because I'm still in that other viewing window. Remember, I can hit zoom and option 6 to go back to that standard viewing window. And then once again, I can use trace. So x equals 1, x equals 2, x equals negative 3, gives me my y equals negative 8. So I can crank out different points using that trace function. Okay, and the last example in this video, what if I want to graph a square root function? So I'll go back into y equals. Your square root function, if you look on your calculator, there's the x squared button, and then above that there's this little radical symbol. And anytime you see a symbol above the button, you can use the second key to access the blue ones. And if you need these green guys, the alpha key accesses that. But for me, I'm trying to access that radical, so I'm going to hit second, and then x squared, there's my radical sign. And then I'm going to put 4 minus x underneath my square root sign. Again, I have a fancy new calculator, so it's putting everything underneath the radical, so this looks great. If you have an older calculator, it'll say square root, and then it'll have an open parenthesis. You type 4 minus x, and then make sure that you close it. Make sure that you close it. All right, when you look at the graph, there we go. Again, if there's, I said before, if you see, nothing for y, that means there's asymptotic behavior, and that was actually a lie because it could also be a domain issue, which I guess is asymptotic as well. So if I type in trace x equals, 1, we get this lovely irrational number, x equals 4, we get y equals 0. If I type x equals 6, for example, I get nothing for y. That's because we're outside of our domain, right? 4 minus x, 4 minus 6 would give us negative 2 under a square root. That's not a real number. And just to give you another example, if we wanted to graph this final equation here, y equals, I'm going to clear out, 3 times the square root, so second square root of x minus 1. Then I use my right arrow to get outside of the square root sign. Or if you have an older calculator, you would close your parentheses. So 3 square root and then x minus 1, close the parentheses, and then you type your plus 2. And there we go.